Hello, everyone, and welcome to Montreal in August 19. So I'll be your host tonight. I'm Emil. You guys might know me from NordSec. So I'll be your host. I will be talking with Towel, our guest for tonight. So Towel will be presenting a challenge in OCaml tonight. A very tricky challenge, I might say. And I guess that well, I hope that you all love it. So please feel free to join the stream so you can react over there and talk on the and talk over there and use your emotes and everything. Also, once Tawal will be done with his presentation, you'll be invited to switch into tables, the table number 1, 2, 3, and 4 on Discord. So please keep the stream open so that if Tawal has anything to add on the challenge or anything, you still hear it. So if Tawal's ready, maybe we can move ahead with the presentation.
Yeah, let me just log into Twitch here.
Yeah, perfect.
So I'm in there as well. Of course.
While we wait, how's it going, Tawal?
It's going pretty well, all things considered in 2020.
Yeah. Yep. So if you want, Tawal, you don't necessarily need to have Twitch open. You can just do your presentation, and then if there's any question popping up on there, I'll be asking them.
Wonderful. Okay.
All right.
I think I actually have it going now. So
Perfect.
we should be set there. So thank you everyone for bearing with me, as I haven't done this before, so this was a first for me. Okay. I don't know. Can you chat in the Twitch stream as well?
Yep.
You guys can chat on the Twitch stream. Well, I guess I'll just leave it up to you to send links there, and I will deal with that later. So hi guys. Let me start streaming then. That is there. And I will move this over to and okay. How is it going? For today's challenge there's 2 challenges that we're going to be going through. The first one is just kind of an introductory one to get everybody warmed up and into the OCaml love that we're going to be going through today. And then the next one is just it'll be harder, and it will test some of the stuff that you did in the first one, as well as some of the stuff in the second one. So starting off, I'm looking at both the Twitch chat here and the Montreal Discord. How many of you guys are like familiar with OCaml or functional languages at all? Am I sharing my screen right? I should be. Yes.
Oh, yep. There's no problem. We can see
Wonderful.
it.
Okay. Well, in that case, should be good to go. Okay, so you guys are seeing my screen well. Wonderful. I'm not seeing any feedback. Am I not asking in the right place, or am I looking in the wrong place?
Some
Also
people have been
possible.
saying no on Twitch. I guess I guess not a lot of people have been doing their some OCaml in their days.
Yeah, that makes sense. I mean, I was hoping I would be able to see that on my Twitch stream here. I apologize. I'm just getting the stream set up so I can get some feedback here. All right. Aha! There we go. That's much better. And now I can confirm that you guys can see this and everything as well. So this is much better. Okay, so if you haven't experienced OCaml or other functional languages before, reverse engineering them can be a little bit tricky, and especially with some pain points that come with OCaml. OCaml is part of the ML family of languages, and it's been around since the mid 90s, I think, roughly 95, 96, somewhere in there. And what's cool about OCaml is you can compile it to JavaScript if you want. You can also compile it into a VM, so it compile to a native OCaml VM, and then you can also compile it to native code, which is what we're going to be looking at today. So today's challenges are all focused on this idea of native code. And my goal with this presentation and walking through the solutions is I'm going to try to stay away from software that it kind of has more of a barrier to entry. So things like IDA and the like that are a little bit more expensive, to put it mildly, and aren't as accessible. So I'll be using Binary Ninja for parts of this, maybe some Red or 2. It depends. You can look at Binary Ninja. There's a cloud platform if you don't have it installed, and then there's also a demo as well, or you can purchase it if you want to support the company or are interested in the software. It's not too expensive, especially compared to IDA, so I figure it's a good compromise. Ghidra is another choice, but with their decompiler, it gets really confused by OCaml out of the box. So gonna stay away from that in this stream as well, because I don't want to have to spend a bunch of time trying to make Ghidra play nice with it, and that's not going to be in the scope of this talk. So for the first thing that we're going to do with the first challenge is just to get you a little bit familiar with OCaml and walking into it. So if you want to follow along here with the challenges and verify them, I have made a small website just to test the challenges if you want to get feedback on your answers. So if you go to 149.28.91.125, you can create an account there, and once you do that, you can download and test the challenges. The second challenge that we're going to be looking at in the stream is not currently available. I'll make that available when we get to it in the stream. You can download it if you want, but the flag exception won't work for it. So if you're having trouble with that, it's because you're moving too fast. So once again, let's go here. So that is where the challenges are live. That's just a temporary site that I threw together literally within the last hour. So feel free to use whatever creds you want on there. It's just going to get all deleted at the end of the CTF anyway. So don't expect that to persist. So going through OCaml, there's a couple things that you should know about. all of the challenges that we're looking at today are going to be statically compiled. Except for the libc stuff. So when you are going through the program, when you choose to do a native compilation for OCaml, you can either target a static or a dynamic binary. The dynamic binary will have the libraries that OCaml uses in its execution externally, and those will have to be required to be installed on the user's machine. We're going to forego that and do static ones. One, because they can be a little bit harder or more daunting because there's more in the code that you have to sort through to get to what you're actually looking at. And then also they're a little bit easier to run in a workshop type like setup like we're doing right now, just because you don't have to install anything, so they should run out of the box. I will say that it does require the libc to be installed, but you're going to have that for most any libc programs you're going to run are going to want that. So we can do that statically as well if you target something like Musl, MUSL, which then you can inline the libc as well and do that statically. But we're not doing that because it's not as common, and this is focused more on getting familiar with OCaml and some of the basic concepts when you're reversing them. So we're going to be looking at statically compiled ones there. If you have trouble running them with the libc, let me know, and I can take a look at it. I'll be going around through the tables. The other thing that we're going to be looking at is, and people might hate this, is they're going to be stripped binaries, which means that the symbols from the binary, and this includes the symbols from the OCaml standard library functions that are statically included inside of the source code, are going to be stripped. So you're not going to get to see those. So one of the things we're going to have to do is figure out how to go from something like that and walk through it to find functions that are of interest to us and kind of sort out what's OCaml standard library and what's not. And we're going to try that with the first binary. Focuses mostly just on that. It's very, very simple. And then I'll show you some techniques that I would use to go through and do that. So that's that. And then the second challenge is going to focus more on some stuff about the OCaml internals. So for the first challenge, the goal is just to get the flag. It's in a standard flag format that you'll recognize, and it's a very, very easy challenge in terms once you find what you need to look at. So once you know where to look in the binary, it's very easy to follow to get into that. However, the way I've written it, it might not be entirely obvious how to get to what you need to look at. So that is going to be the kind of goal here, is sifting through OCaml libraries, finding the initialization routines for how it runs, and trying to work from that, which it shouldn't be too terribly hard. It's just the first challenge, and I'll go through some techniques for how to handle that after the stream. And again, you can test the flags that you get over here, but it should be fairly obvious once you have the flag because it's in a flag format. So go ahead and pull that down, and just the only hint that I will give you for the first challenge, we're going to just dive right into it first, and then kind of go from there. Is that OCaml, if you've ever reversed Golang or Rust, it's similar to that, where instead of having your libc routine point to directly main once it's done setting all that up, like you would with something like C if you compiled that, is there's going to be functions in there that are equivalent to caml main. So OCaml is a functional language, which for the purposes of most intro to reverse engineering, it will mean that we're going to be looking for a lot of high order functions. So that is functions being passed as arguments to other functions. So that's going to be a common paradigm in reversing OCaml and other functional programming languages. You're also going to see a lot of recursion. So a function that calls itself. You're going to see that a lot in OCaml because it's part of this recursive paradigm where instead of working iteratively through things in a for loop like 0, 1, 2, you will map or fold over data structures, which means that you'll usually see something to accumulate values, and then a specific value you're passing into that as an instance, and then calling that same function again, which in the assembly will be something that we're going to look out for, because once you can kind of figure out and realize where those structures are and get more familiar with them and kind of eyeballing those recursive structures, everything kind of gets a whole lot easier, and you start to see through the mist of what's going on. So for this first challenge, we're going to go ahead and get started on that, and you can break into your tables. The goal here with this is to look into it and try to find the main function of the program, and then once you do that, finding the actual flag once you've found the main function of the program should not be too difficult at all. So go ahead and get started with that, and if you have questions, I think it's okay to ask on Twitch. I'll go around through the tables as well. And good luck.
Thank you, Towel. So I invite everyone to break out into different tables. Just feel free to join any of them, and then also keep the stream open, because if Towel wants to do an intervention that give a tip or something, you definitely don't want to miss that. So it will be easier for you to hear it if you are on the stream. And yeah, so happy hacking.
and over again. I'm jumping through hoops, so you don't have to. Making you smile as long as I can. Storm clouds are coming, and it's best if you prepare. But if we get tomorrow, I promise I can try. Give you love to borrow, if just to get us by. And sometime when you're ready, I'll soften up the blow. Our love was never made to last, and I don't wanna give you back to hold on to. Not enough give. I let you hear music and cover your bruises. So if we get tomorrow, I promise I can try. Give you love to borrow, if just to get us by. Sometime when you're ready, I'll soften up the blow. Our love was never made to last, and I don't wanna give you back to hold on to.
Another kid, making my wish come true like a genie. Holding up the glass in the club too steamy. Not a race horse, you're a black Lamborghini. Some people might think you're sleazy. You're so fine, though you're making look easy. So much you can make a man green. So don't stop, go ahead and get freaky. You got me wanting to be with you. So sexy, I don't know what to do. Your curves are making my dreams come true. The way I fashion be taboo. Just be naughty, move like a bro, girl, it ain't no hobby. Looking so good, gotta tell somebody. Blows my mind when I see a hot body. Hot body. Makes me wanna fall in love. Makes me wanna fall in love. Don't stop now, just get naughty. Move like a bro, girl, it ain't no hobby. Looking so good, gotta tell somebody. Blows my mind when I see a hot body. Hot body. Makes me wanna fall in love. Hot body. Stand upon the ledge so high, like we are not afraid to die. You're wild, oh then you smile, and turn the sound up so loud, turn me around, like a wolf you have to learn. Oh, you brought me to life. I'm revived.
Hello, everyone. Let's see where we are. Yep. So, I am releasing now a hint for the challenge, since we still have no solvers, and it's a lot to get started with. If you've never done it, let's see if we can't get my screen. Okay, the screen is shared. Wonderful. So the did somebody solve it? Oh, let me see. We have to see about that. Scoreboard. Nope, still no solves. So, Nick Lovin, you are lying. So, anyways, the hint is this is a OCaml program that you'll see on the screen here. At the unit start, we're just letting that equal to main, and that will be what runs in the program. So if we save that and go down here, if we run the program, we see that it just prints out the message. I will be releasing, I've compiled this program with the exact same settings that the first challenge baby was built with, and I have released it to you with symbols included over here. So if you refresh the page, you have clear your cache to do that. Here you'll find the hint file, and that's an empty program, and that corresponds exactly to the source that you see right here. So all it has is one main function that prints a string. As you've probably noticed by now, and I've mentioned this to a couple people on the different tables, is two things. One, you'll see strings in the output that aren't in the source file. That would make it way too easy, and you would we're not going to let you get off that easy looking at and delving into the startup routine for OCaml. So check out the hint file here, and you can see what the startup routine and what that empty program looks like, because that one has symbols in it, and then you can kind of take some of that knowledge and try to map it back to the program that you have in front of you. We'll just see if that helps you guys out some. I've also seen on the Discord some people saying they were using Ghidra, and the compiler was very confused. I did try to mention that earlier, that the OCaml calling convention is non-standard. So when you have a typical x86 natively compiled binary, it expects the typical calling convention, and it uses that assumption to generate part of the decompiled code. But in OCaml, that assumption is invalid, and it has a different calling convention. And I'm not super familiar with Ghidra, and I have not tried it myself. So there may be a plugin or something that would apply that, and if not, I encourage you all to go out and investigate those tools and write one yourself and get into the OCaml verse and join the fun. But for right now, as far as I know, there isn't one for Ghidra, and I'm not going into setting that up. But you could make one. We'll look at the flag that doesn't work with you in a second. Nickel Oven, once I'm off the stream. So good luck there. Use the hint program, and I'm going to go and sort that out. So if you don't need anything dynamic as well to solve this, you don't really need a debugger. It could help you. It might help you, going through dynamically, but the solution that I'll be presenting shortly will be entirely static. So look forward to that, and good luck, everyone. Carry on.
what you said I get. Don't care if you forget me. I just want there to be more. You can't wait to be remembered, just like the kids before. Take me to the promised land. It's what you said I'd get. It's what you said I get. I don't care if you forget me. I just want there to be.
Hello, just to let you know, the challenge still does work as intended, and the flag is right in the database. I know there was a little confusion, but everything still works. We have one person who's very close and got an incorrect flag, but is very, very close. So we should be seeing a solve semi-recently. So if you're close, get those flags and get first blood, because we're almost there. So, 11, almost there.
I'm terrified and loving it. Want no regrets to keep me up at night. Feel so alive and loving it. Had to survive, so I finally learned to fight. Laughter, we cried for the fun of it. Now I finally see the light. Don't wanna waste a single minute. Now I finally have you, got you by my side. Let's fuck it up and repeat mistakes. It's just a game to play. So let's hit the ground running. Yeah, let's
Hello, I just wanted to give a shout out. We have our first 2 solves. The first solve was by Manamo. I don't know if he's or she is on Discord, but congratulations to Manamo for getting the first solve. And shortly afterwards, Shill came in with a second place solve at 100 points. So I think we'll let a few more solves go through and then walk through the solution. And then we can move on to the next challenge, which it tests a rather difficult concept of OCaml reverse engineering. So if you've never had the pleasure of getting to the more advanced stuff, after you have a bit of an idea of what the structure of these programs looks like, that's going to be very helpful. So good luck in finishing up, and congratulations to both Manamo and Chill, and we will see who gets the third place solve here. All right. Carry on.
shaking out pictures of us. I never realized what I have lost. Now I know it, and it is so insane how I treated this like a game. You were my help when no one else were there to share affection. So let's try again. I'll go anywhere. Just send me your location to bring back when we were more than happy. Jokes and laughing, trust and loving, yeah. We were storm and fire, both on fire, more than happy, yeah. I think we can rescue this. Just put the love first and taking the risk. 'Cause you're what I need and I'm what you need. You get my heart to feel, you get my heart to
Merry Christmas! Ho, 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 ho.
I am still dancing on the feelings that you gave me. 'Cause all of the waves, they keep chasing after me. Even though we are out of reach, I can feel the water on my feet. The things that you said to me, they will grow inside, they make believe. I am still dancing on the feelings that you gave me. I am still dancing on the feelings that you give me. Under the northern lights, our love was shining bright, shining bright. It was a cold, cold night. You wrapped my heart so tight, and I faced the skies up above the heaven's eye. And I dreamed that I would always be alright. So won't you come to me, and darling, let's survive. Yes, come to me, and darling, let's survive. And I face the skies up above the heaven's eye. And I dreamed that I would always be alright.
seem to let it eat me up. You influence my frame of mind. My heart is stuck in a loop of your rhythm and right. I try to replace you with something new, whilst my body drives heartbreak along the ground. Dancing about the idea of you, whilst you decide if I belong to lost and found. You know I'm dying to reach out to you. I'm trying but you can't see. You say my calls never come through. Why can't you just hear me? I'm crying 'cause I can't feel you. My heart's sinking to my feet. I'm lying 'cause I can't touch you. Why can't you just hear me? It seems to have impact on me. I feel pain every time you cry. You say you'll be back before I know it. Why'd you always lie? I try to get on with somebody that's not you, whilst I hide the pain that sits before my eyes. Dreaming about the idea of you, whilst you decide if I fall or if I fly. You know I'm dying to reach out to you. I'm trying but you can't see. You say my calls never come through. Why can't you just hear me? I'm crying 'cause I can't feel you. My heart's sinking to my feet. I'm lying 'cause I can't touch you. Why can't you just hear me? I'm trying but you can't see. You say my calls never come through. Why can't you just hear me? Why can't you just hear me? Yeah. Like I said, I don't wanna be lonely tonight. So come on over, need you close to you, it just feels right. If it didn't take you so long to realize that I'm not faced, I just want you to be alright. From the first I love you to the last, I promise I'll catch you 'cause you fall like 100 times. And every time I ever tell you lies, that's not I think about that tonight. And no worries, no stress, no trouble. It'll be fine when you wake up tomorrow. If you ever find yourself in a struggle, I'm not faced. I'm hoping I'm the only one you want tonight. So come on over, need you closer, oh it just feels right. I wish it didn't take you so long to realize that I'm not faced, I'm not faced. From the first I love you to the last, I promise I'll catch you 'cause you fall like 100 times. And every time I ever tell you lies, that's not think about that tonight. And no worries, no stress, no trouble. It'll be fine when you wake up tomorrow. And if you ever find yourself in a struggle, I'm not faced.
Welcome back. So it looks like that was a bit of trouble for some people, but I want to give a huge shout out to Manamo for getting the first solve here, Shill for coming up in second, and Doom for coming up in third. That was, as far as like a first OCaml program goes, tricky, but I think it's going to be very valuable as once we walk through it all and you kind of have an idea now of what to be looking for and how that whole startup routine can look like in OCaml. So huge shout out to you three for getting your solutions in, and let's go ahead and jump into the solution. Now, we're going to solve this entirely statically with no dynamic analysis at all. So if we hop into Binary Ninja here, we're going to start by opening an existing file, and then we're going to first look at the empty program. This was the hint that I sent out on the site here. So if you look at the challenges under baby, you can see the hint file. This is this one right here. This is basically a hello world in OCaml. However, the symbols are added in as well, so you can get an idea of what it looks like to walk through and find the camel main in a program that has those symbols, which makes it easier. And then you can take that logic and apply it to other programs, or do something else, as we'll see here in a minute. Now, if you'll see in the bottom left down here, let me know if you guys are having issues seeing any of the information on the screen. I'm not entirely sure if the stream looks okay size-wise, but I think we're okay. See, it's still analyzing the program, even though it has symbols. So we'll just let it do that for a little bit, so we can give you the most complete picture. But you can see already that we're seeing a lot of functions over here on the left in the function view of Binary Ninja. A lot of them you'll see are camel, standard lib, and then some stuff. So those are part of the OCaml standard library and are kind of pointless for us to be reversing. But if the binary is stripped, we need to find a way to avoid those and get to the code that we're actually looking to. And to do that, we're gonna walk through the OCaml initialization routine to see where it gets to the main function of the binary, like you would be able to do with other ones. So I've also got some symbols loaded on here. So these ones are from libc, which as I remembered is dynamically linked in the binary, but OCaml's runtime is statically included to make it so we are forced to learn how that looks and get into it. So some of the things you'll see in here are things like curry 4 and curry 3, 2, and 1, and apply as well. The apply functions you'll see really common in OCaml's fold and map implementations. Anything that's taking a function from somewhere and some arguments and applying one element of it to the function. That's like a common functional paradigm, and OCaml uses that to these functions as part of that. So you can see where it's calling RSI, and it's calling that in from a variable on the stack there, and then calling it. So you'll see that type of first order function. So if you see the caml apply and caml currying is there to make like essentially, well, it's kind of like a local scope and like an absolute terrible rendition of the concept, but it's like a local scope that you'll have for some function, and then you can kind of keep the arguments off to the side and pull them in as you go and curry them. And if you're not familiar with those concepts, it's more of a functional programming idea. But if you see in a non-stripped binary these functions, you should trigger in your mind to be thinking of, okay, well, does this look like a fold pattern, a fold right pattern, a map, something like that, because that's when you're going to start to see those recursive structures play out. So that's just a little tip that for when you look at and you figure out what those symbols are to how to use those when you're reverse engineering the program. But when you first get to the binary, let's go to the start symbol. Yeah, so this is the entry point right here. And this is your standard libc initialization routine that you'll see if you were to compile a standard C program, right? So the entry point starts the libc routine here, and this will call constructors and whatnot. And then this argument into RDI right here, which is in the standard calling convention, the first the address of the main function of the program. And then those arguments are passed into the libc routine, which starts main. So since OCaml is natively compiled and still uses libc, we still have this routine. But after libc's initialization is run, this is not the main function of our program, but it's actually the main function of OCaml's initialization routine. So we've got libc's initialization routine, which we know how to skip by looking into RDI. And then we've got OCaml's initialization routine, which we need to kind of walk through and learn how to skip. So if you go into main here, there's a call to caml main and a call to caml sysexit. Common thing when you're looking at the OCaml initialization startup is that the last function call is almost always just some form of caml's exit. So if you kind of go one up from whatever it is, that's usually what's going to be relevant. So let's go into caml main here, and then there's caml startup, and then caml startup common, and then this is just checking for exceptions to see whether or not they were caught and what return status to throw. So we're just going to go into the startup, and then you get to this huge function right here. You see I've got the call graph on the right here. The interesting point of this call graph is you can kind of skip everything. It's basically got the exact same structure in most programs compiled in this form. And what you're going to want to look for is a call to right here at the bottom left of the screen. Oh, I can't see that because of the Discord message. So yeah, right down here there's a little block. Yeah, so this little block right here on the left, that is going to contain the next function you're going to want to go to, and that is the caml start program. If you weren't sure exactly which function you wanted to go through, you could walk through and just kind of read the names. So parsing runtime parameters, auxiliary startup stuff, initializing the floats. Remember, OCaml is a garbage collected language, so that's what you're seeing right here. So it's got to set up all the garbage collection. It's got some globals that it'll pass around to keep through it, and it's got something called a young pointer, which we'll look at briefly in a minute, and we'll see soon. But basically, that is like a fast heap, like a small version of the OCaml internal heap implementation. But again, we don't really need that. This is just a simple binary. So we're on the search for the main function of the program. So if you go into caml start program, things will start to look a little bit better. The only call that you're going to see in here after some register and stack setup, and then again finishing up that register and stack setup. So this is the young pointer, the bottom of the stack, the last return address, and the garbage collector registers. So and then the exception pointer. So it's setting up all those globals and function. That's a bad way to use the word functional. The runtime necessity values that aren't necessarily strictly our main program. It's kind of setting all those up in the registers, and then it can go in to start the caml program, and that'll start. It'll use those types of things, call our main function, and then do the exit, as we'll see. So let's step into that. And then in here you'll see there's the exit right here. So that is calling exit. So again, exit is the last thing that's called, just like we saw before. So again, looking for that pattern. And then the thing right before exit is called is the empty program code begin. You can see. So when your OCaml code is compiled natively like this, it'll put the name of your binary and functions in the description of the function name. So in a quasi way, it's similar to C++ with the name mangling, where that'll get mixed in a weird format. I guess it's closer to Python's name mangling for symbols inside of it. But that is what you're seeing here. So caml is just letting us know it's an OCaml function, and then empty prog is the name of the program. It's empty prog, and then code begin, and that's where the code will begin. So let's just step into that, and then we can see it's moving this string into RAX, and then if we hover over it, we can see that the value of the string is at that address is hello Monterey hack from OCaml, and then it's printing it with an end line, and there we go. So what's interesting about this, and this is the reason that you have so much trouble looking at OCaml programs in something like Ghidra, is look how the argument is passed to this function. In a typical x64 Linux calling convention, you'd expect to see that first argument passed via the RDI register, very similar to how it was done in start here. This is like standard C calling convention. C main is the first argument, and it's passed via RDI. Over here, OCaml uses its own custom calling convention when it gets down into the internals. And so for a program like Ghidra that makes these assumptions about what it expects the calling convention to be, when those are violated and we're passing our first argument via RAX here, Ghidra gets really confused and the decompilation suffers as a result. That's why one of the reasons I'm looking all at assembly here, just because it's easier in my head, and then we're not sacrificing the information trying to assume that the decompiler will give us that correct code. So this is that string that we're going to print, and then it just prints it, and there we go. And there's our whole program. So if we were to, using that information now, look and open up the challenge binary. Let's see, which one is that? That would be baby release. Okay, here we go. If we open this one up, it's going to analyze in the bottom right, and I'm going to go ahead and let it do that. So while it analyzes, I'm going to show you one other way that you could use Binary Ninja specifically to help with this, but this concept will apply to other things. And that is the idea of adding signatures by hand, sort of, into the executable that you're looking at. So if we go back and we open up under, where did I release it? I think it was under sig build. Empty program, yeah. If we open this back up again, what we could do is there's a plugin for Binary Ninja, and there are similar ones for other binary analysis tools that you can build a signature database from a given specification, and then look for those signatures in other programs to apply the names and get some sort of insight into to a stripped executable like what we're seeing here. So for this one, for example, we could do, there's one called I believe it's SigKit. And then you could go down to generate signature library for it. And that would let you build a signature file, which you could then apply to a stripped version to get some of those symbols back. And you'll see that I have one of them, a couple of them already added into a local signature library. And so from that, we've got an empty program signature. So if we went to our Binary Ninja folder, that's a hidden folder right now. I'm not going to deal with that. Anyways, you would just save the program signature in a directory that the SIG toolkit could look to find it. And then once it's done with regular analysis, it'll add those signatures into the binary. So I've got one built for a different signature program, which was slightly different. So it doesn't have all of the symbols, but you'll see what I mean with this second one. So let me go and let's see. Plugin folder. Yeah, so if you go into manage plugins and then signature kit plugin, SigKit plugin, this is the one that I'm at least using for this example. And there are similar things like the Flirt signatures for IDA Pro, and I'm assuming there are equivalents for Ghidra as well, and your other binary analysis tools. So keeping these types of things in mind can be really helpful. So if you wanted to do this one, you could just install it, and that's where it came from down here. That's how you could do that in Binary Ninja. But let's go back to now we're looking at the baby program, and I've got some base symbols in here. So if you look on the left here, we've got things like OCaml, standard lib bytes, a few other things, all marked execute symbol, process suspending symbols, like just a few. I built this from a target that was pretty different from the original one. That's where it's pulling up these signatures from, is one of a pre-made signature file that I made. And it's getting a good number of symbols in here. So that's everything that's in this yellowy orangish color. So for example, OCaml MD5 final update and transform, init garbage collector, that type of stuff. So we can go ahead and follow through that same execution path that we just walked through, but this time without symbols. So this is, again, a very different symbol pack. So like not everything was made from it the exact same. So it was like a different compilation setting and stuff. So we don't have all the symbols we'd look for. But again, we should know that this should be our main function because this is the libc routine. So let's just hop into there, and then OCaml startup. This one we have a symbol for. OCaml startup again, startup common, and then here's that big graph that we were looking for before. We know that the solution, I mean, like the next function that we're going to want to look to, that OCaml program start, is going to be down in here. And then we're looking for something into R12. That's this function. And then if this one is the exit routine, then this should be main. And then we have now found the main function of the challenge binary. So we can go ahead and rename this to challenge main. Okay, and so now we have the main function of the binary. Now, looking through it, there's not a whole lot in here, but there are some calls. But if we look, kind of staring at us right in the face right off the bat, is these integer values are moved into RDI and then compared against a value that is sourced from this displacement from the RAX registered that's dereferenced. And it's done in blocks of 8 bytes. So let's just change the display type of this one to a character constant. So that says getting underscore display as another one, and then we could do this last one as that. And so right there we can see that this string is compared, and this string is compared, and this string is compared. So if we were to go into the program right now and If we enter in nothing, we get nope, try again. And then if we were to enter in this string that we're seeing right here, and now the last letter is sticking out right here. It's the P, and then these are null bytes right here. It's just because the comparison has to be done on 8 bytes in order to make this 64-bit comparison operator work, so that you have to have the nulls in there as well, which is why that last character is down there. And then if we were to run that, we can get the flag that solves the challenge. So that's the idea with this one. Now I kind of jumped right into looking at this text and then inputting it here. But if you weren't exactly sure, now that you have found where the main function is in the binary, you could go in here and just set breakpoints, right? So you could look at 402.667 here and set a breakpoint there, and then run the program in your debugger and see exactly what it's comparing. The other thing is that you'll see it is exiting early if a condition is not met, and that's just checking if you how many arguments have passed, and that's what it's checking here. But if you notice that the value check here isn't exactly shill garbage collected or just straight garbage. That's funny. The value that it's checking for is against 5, which is kind of weird. And the reason for that is that integers in OCaml are stored in a very unique way, and this is the point that we're going to be looking at for in the second and last challenge for this Montre hack session. So before I move on, are there questions about like the solution of this? The way we just went through it. I know it's it's so simple when you can see the solution, and then it's like, oh yeah, obviously. But when you're the one who has to sit there and figure it out, it's a lot harder. But hopefully now you can see those patterns and recognize them. Any questions? Nope. Okay, I don't see anyone typing either, so we're gonna go ahead and move on to the second challenge here. So the second challenge is dealing with the representation of integers in OCaml. So integers in OCaml aren't stored the way you would expect them to be. The string that you just saw in the comparison was stored as an integer because it was printable and it could be, and it was an optimization OCaml made for the string. However, integers themselves, when they're stored, are stored in a bit of a funky manner, and that's because the two basic types that you'll see in like the internals of OCaml are a pointer and an integer. So let's see. Yeah, so we don't need this anymore at the moment. Okay, so if I've already written a function right here, this is just well, let me make that a bit bigger here. Yeah, so so this showed a data type function takes a tick A and returns a string of either integer or non-integer, and it looks at what OCaml considers the internal representation of that object. This is different from the type of the object isn't the right word, but it's the idea. It's different than the type of the value. So it's not something like tick A or bool or function taking, returning, whatever, or unit. It's the literal object representation during compilation. It's what you see here is that it takes a tick A and it returns a string, and it's a function. So that if we use this, we can see if we show type on something like 1337, it's an integer. That's what OCaml will consider that to be. But if we do it on something like a string mantra hack, that is a non-integer, and it basically boils down to a pointer. And because we're on a 64-bit machine, it's going to be word aligned, and so the bottom 3 bits of the pointer value are going to be 0. And if OCaml and its comparisons has to determine if something is an integer or a non-integer a lot during execution, so it's kind of like a neat optimization. What OCaml will do is use the bottom 3 bits of whatever the value is, integer or non-integer, to store metadata information. This is analogous to what you'll see with pointers in the heap. So if you're looking at a heap space in the libc binary, there's free and then different bits inside of the metadata space for it for an entry in the heap. And those will tell you, if the block is free, some other information about allocation, that type of stuff. So basically flags that are in the value. But because it's safe to do for pointers doesn't necessarily mean it's safe to do for integers. Because if the integer happens to have values in the bottom 3 bits, it's going to be lost. So what ends up happening is that they shift integers to the left 1 and then OR them with 1 to set the flag. So, for example, if we had 10 as an integer, right? If we wanted to encode this in OCaml, we would shift it left by 1 and then OR it with 1 to set the flag saying, hey, this is an integer. And when you do that, so the representation of it would actually be 21. And to better exemplify this, I've made a quick program here. It's based off of the same empty program we saw before, where we just we make an integer n, and it's the value of 1337, and we print it to the screen, and then we print a new line character, so everything looks nice. And let's go ahead and we see that it prints 1337. So that's what OCaml looks like when it executes the OCaml program. But if we were to hop into a editor here, or something like Binary Ninja, do I have a session open? No. Okay. So let's open up that integer example we just ran. Step through back to where we know we're going. We could do it through the function since we pull this, but I figure I'll just show this again to be complete and verbose here. Here's our little function. We'll go down to the start program and then set to R12, go back up from 2, and here we go. So we don't see the hex of 1337, which is the integer that we're printing, is 539 if you didn't know, but 539 is not in the list. However, the thing that's being made a string of integer in this caml function is A73. So if we look, if we take 1337, if we shift it left 1 bit and then OR it with 1, now we get A73. So that is the encoding of that integer in OCaml for its representation, because now it can just do a single bit test on the least significant bit to know that this is an integer type and not that pointer type. And so you'll see that all over the place in OCaml. And because of that, it kind of naturally obfuscates integers. And so to help you guys test and get experience with that, there's the second challenge is up now. It's Teenager. The flag submission for it is now open. This thing will allow you to test integer comprehension and allow you to practice again looking for the main function. You'll also see some recursive data structures in there, some maps and folds rights and stuff. So you can kind of look out for those recursive representation, but keep an eye on the integers. I would also recommend setting breakpoints in the debugger, like we showed. Like I mentioned earlier, once you find a function you want to look at, set a breakpoint in it and step through, because the calling convention is a little wonky and there's that garbage collector, and so being able to step through and see where everything is actually in a debugger can help a lot, especially with this challenge. So look for those integers stored in a wacky representation and see if you can solve this. We don't have a whole lot of time left in this Montre hack because we took a long time with that intro challenge, but I think it was an important intro challenge to do. So I don't know if we'll actually present the solution to this one. I might just throw it up on the Ring 0 CTF if Mr. Unicoder will take it. But go ahead and do your best at it, and I will be in the Discord and on Twitch if you have any questions. So good luck with this. Remember, it's just shift left or 1 will encode an integer, so if you want to decode it, you just undo the OR with 1 and then shift it back right. So good luck.
fighter in this battle of the sand. I don't wanna be the lone survivor. Can we defend the land we conquered back in high command? I don't wanna be the only driver. Settle down today, we'll find a way to run towards what we have made. Take my hand and drive tonight. We'll find a way to bring back sunlight. We will find a way. Don't tell me I'll find a way. Don't break me, I'm here to stay. All these dreams go passing by. We'll find a way to bring back sunlight. Don't tempt me, I'll find a way. We will find a way. We will find a way. We will find a way. Don't tell me I'll find a way. Don't break me, I'm here to stay. All these dreams go passing by. We'll find a way to bring back sunlight. Don't tempt me, I'll find a way. We will find a way. Don't wanna be the only commander. I'll settle for the last remaining dancer. Can we take flight and do what's right? Damage the side of modern life. Don't wanna be the lone survivor.
Okay. So that was not a whole lot of time of being able to do practice at the solution, but even so, and I know the binary was available earlier and the flag submission was just opened for it when you guys started the challenge, but we have one solve from Manamo, who also got first solve on the first challenge that we presented, the warm-up, the baby challenge. So congrats to Manamo. I don't know if you are in the Discord or just joined from Twitter or elsewhere and are participating for fun, but congratulations and big shout out to you. I want to see if people want me to go over the solution in more detail for this one, or if we should leave it the way it is and I won't spoil everything, so you could try it on something like Ring Zero Team. So, any thoughts on that?
I personally think we should go ahead with solution if you do have some time for it, because I would love to see it personally.
I got one more person here typing. Okay, well, here's what I'll do. I'll go over basically the logic of what you need to realize and start going through to do it, but won't go through every single step, so you can still have the fun of going through it. I think I probably will make the challenge a little bit more difficult for Ring Zero Team. It honestly wasn't this challenge isn't terribly difficult once you realize what's going on. So this is the binary you are all looking at, teenager. If you let's go. Yeah, so just another graph. Okay, and that is spoilers. All right. So as was mentioned in Discord, my binary Ninja instance analyzed it a little bit faster because it's the multi-threaded version. The other version are not multi-threaded, so it'll analyze a little slower, but it'll still get the job done. And even if you don't want to use Binary Ninja, because we're not using anything that's super Binary Ninja specific, it's just nice to stream with because it's nice and graphical, so there's good representations of it. It's easy for people to install. There's a cloud version, all that type of stuff makes it, I think, a good choice to work with in a format like this. So for the solution to this one, let's see. For this one, we have the binary. This time it actually prompts us for a password, and then we could enter in some stuff, and it says that it's wrong and to try again. So because we can, we've got a string right here, and then we've also got an input hang. We could SIGINT the binary and then walk the stack call back to find where the main function was that called it if we wanted to. Or we could try and do something like a strings view here and try to find the string that way. So for example, this one is called from over here, and then that gets us to the main function just from a string reference. I encrypted the strings and then decrypted them at runtime for the first challenge, so you couldn't just do that. So you were forced to go through and look at the initialization routine for OCaml. But for this one, we've already done that before. But just in case, for good practice, I've again got some symbols over here from the from one of my signatures I've loaded. So let's see if we go. Here's the Camel main startup, JCaml startup, Camel startup, common startup, and then here's Camel program. And where's an R12? There it is. And 2up should be our main. And this is that same function we just found from the strings. So if you look through this one, it's a lot of data being moved around on the stack, and then a function call, and then some more data being moved around. And we can look at that with, that's the type of thing that if I were looking at this, I would look at in a debugger and see what it is there. If it's not obvious from what's there in memory, it's just ones and zeros, which is a little bit wonky. So there's not too much to do there, but if you were to look at that in a debugger, it would be a little bit clearer. There's also some function calls here and some things moved into REX, so we'll know that those are going to be the first argument. And what we can deduce here is if we look at the address of this, it's Monterey Hack. So this is the address of a string right here, so we can assume that this is some print function. This Monterey Hack string and this one right here both seem to be new line terminated, so we can go ahead and rename that as some print string function equivalent. Something like that. And then this one, we don't see anything, so we might want to look into what that is. I've got you can kind of get an impression of what that might be just by, again, looking at what the execution was it waited for input. So you'd expect to see an input somewhere in here. And then this is another function. So again, debugging would help sort out what that is and what it isn't. Then if we go down a little bit further, there's a comparison right here on 2B. Now, I'm going to just say this again, is go through that in a debugger and see what it looks like. But 2B, if we were to look at that in Python, let's Okay, so that is the integer value 21, not 43. Remember, this is unpacking the integer structure of Python. I mean, of OCaml using Python. So we've XORed it with 1 to unflip that bit in case it was set, and then shift it right 1 to undo the shift. So it's comparing something with the value 21. Even if you were just guessing at that, you might know what that is. That would be the string length of the function. So with that, you might assume that this would get the string length, and then this would read the input. So you could do something like that, and then get input there, and kind of make a guess, and then go and check in the debugger, or go in the debugger, confirm, and then change the symbols, but that type of thing. So then if it is equal to that, we go down this branch right here. Otherwise, we go down this branch, which prints a string again. So we can expect this to be a string. And that would say that it's wrong. So we know that this is clearly a bad path, and this is the wrong string. And then we'd exit. And then if we look, this function only hits if the length is that way. So I would say that's checking the length of our input. And then it does some sort of computation in here. Now this is an old symbol that I put in that it's kind of like a trick symbol for me to find important functions in OCaml, but that's like a personal signature, so I wouldn't worry about the name there being strange. What is interesting here is this final check. So we've got these are the two branches that happen before we get to print string. And in this one, the value in rex, which is our first argument, is the wrong try again string. So this is clearly the branch we want to avoid. And then in this one, we are moving some data into rex, calling this standard lib digest code begin. So this is coming again from my signature library that I added in for OCaml. So we know it's calling some sort of digest on this value. And then doing some function with it, and then this data, which is the success flag, you can see that in there is the value at that address is moved into rex, which is the first value. So, and then that result is printed. So this is also clearly the correct branch, and I would assume therefore that this is probably our input, because what else is it going to hash if it's building a flag? So that's what it's looking for. So then the question is, well, how do we get to this positive branch? And the comparison is against rex here being D9F. And if we were to unpack D9F, it's 1743. So we would want, at this point, rex to be 1743. Now we get to go through the fun part and look at, okay, well, what's going on in the rest of here to figure out what exactly is 1743, and how can we make that number happen? So that is coming from this call right here, and then we've got a list fold right that's coming from the signatures. So again, this is just standard lib fold right. So this is some sort of recursive function, and then as I mentioned in the last solution we were going over, apply to right there. So we're going to see another function having something applied to it inside of a fold right context. That's something to look for, and then we're adding a value to the stack as well. So I would step into this with the debugger and see exactly what values it's iterating over, and then let's see what else. There's some data in there. And then it's a very similar structure in here with recursive stuff going around. So there's that call RDI right there. Well, what exactly is RDI there? And then this is another recursive section. So I have that marked as well. So that's all very interesting. And then because we're in the main section, the other thing you can just do as like a trick is just scroll up, because we have all of this data getting pushed over here. So if we wanted to figure out exactly what that is, it looks to be just a whole bunch of ones, and so it's like, okay, well, what is that? And if you were to step through in a debugger at this code, you could see what values were being called recursively, and because they're actually our code and it's not some standard library function, we can expect them to be fairly close to our main function as well. And if we scroll up, that is what we eventually see is these types of patterned functions right here. So it's a very similar pattern where we've got move, add, ret, and then the call, do some stuff. There's a comparison, and then a jump over a value depending on the result of the comparison, which sets the return value of whatever this pseudo function is right in here. And then that's returned on the stack. So, and then we see that pattern is kind of repeated over and over and over again. So we've got a value that we might jump over depending on this comparison, which happens with this. And it turns out that this is actually checking the bytes of our input. And if we wanted to undo these comparisons, we could look at it in a debugger or write a script or what have you. You could even just do it directly from the assembly with some pattern matching, because what it's doing, so say for example this value, let's copy that and unpack the integer, and it's 60189205248. This is going to be compared against some byte of our input, and so we can look through to see, okay, well, some transformation must happen. It looks like it's multiplication with this value, which again we can unpack if we wanted to, and then we get a different value. So some value multiplied by this is then gonna eventually look have to have that value encoded, and so you'd go through and see what this actual check is doing, and then there's one per character, because if we look through, there's, I think, what is it, 21, 22, yeah, something like that, one for every character, and then the results that it is returning are what's interesting. So that you should also be looking at in a debugger to see, okay, well, what is the return value if it's equal? Well, you see this move rack 7, adjust the stack pointer, and return. Binary Ninja thinks that's part of the same function, and in a sense it's right, because look where the target of this jump is if they're equal. It's going up to this function over here and then returning from this section of code. And if we go into, for example, pick one at random, this function, that's too random. Right here, if we go to the jump, it's again that same value of 0xA7. So let's unpack 0xA7, that's 83. And the value that we're looking for is 1743. So let's just factor 1743. And we see that 83 is in fact a factor. So if we were to hit every single one of these comparisons, we would know that the resultant value, if we did 83 times 21, is in fact 1743. And there are, again, 21 of these functions, so that would give us the target value for the solution. So we could solve these equations just by unwrapping the OCaml integer representation and get our solution. So for example, this one is XOR with this value and then the compare. So that is the general walkthrough of this solution. And again, shout out to Minamo for getting that in the amount of time given. That was impressive. I mean, I know the challenge was released earlier, but still, that's worth repeating. That was very impressive. So, congratulations. Yeah, Cyber Slash. Let's see. So this conversation is in regard to a challenge from NorthSec 2020, which was QR scanner, which was the hardest reversing challenge that I made for the CTF. And while no one solved it during the CTF, there is now a public write-up, and this is an extremely hard OCaml reverse engineering challenge if you're looking for a more difficult challenge that's really difficult both in terms of the actual reverse engineering to look at the data structures and the recursion that's going on and how the program's being evaluated, although it is pretty similar to this one because I wanted to have somewhere to go next. But then also trying to solve the actual problem embedded in the binary to get the flag once you understand what everything's doing is also, I'd say, non-trivial. So if you're looking for a harder challenge, you can go and check that out.
Thank you very much, Towel. And please, everyone, thank Towel for this amazing presentation and challenge. This was like the clearest reverse engineering presentation I've ever seen. And it was in OCaml. So thank you very much for that. So yeah, I have a small question for you, and I'm sure you get this question all the time. But how do you come up with those OCaml like challenges? Like, what drives you behind this?
So when I go to make a challenge, specifically for Sec specifically, is I don't want to make something that is a clone of something else. So if there's another challenge in another CTF that has the same topic, for me, it's not very interesting to kind of build the exact same thing. So I want to have something new or interesting in it, so that whenever you go to reverse engineer it, there's something in there. And then I want the challenge to have value as well. So if you learn it, you might if you solve it, you might have something you've learned along the way that you can bring back into what you do outside of CTF. So in the past, NorthSec 2018 or 17, I made a challenge that was a virtual machine challenge that called Mars Analytica, which was built with a virtual machine representation, which is common in CTFs. You'll see that in hardware reverse engineerings, but the design of the virtual machine engine was unique in the fact that it was more like a ROP system, so it would calculate an address based on what was going on in memory at the time and just jump to that location instead of having a byte code that it would parse over with something like a switch case statement on the different byte values, which made the virtual machine somewhat unique in that aspect. So OCaml is very good at that because it brings in something new, because it's not very common to have reverse engineered OCaml before, so doing that is gaining new experience, and no one's done it before in terms of a CTF challenge that I've seen. So it was something new to add. And then there's actual pretty interesting technical challenge in there as well, because the way that it encodes integers is very unique, recursive data structures, and figuring all that out is also very unique from a reverse engineering point. So I just try to find stuff that will bring that to the table. The only other thing that's different from like a non-reverse engineering perspective that I try to come up with is a good way to validate the flag that you give. So if you reverse engineer something really, really complicated, but at the end of the day it's just a string comparison, there's a high chance that you can just avoid the reverse engineering or find some unintended solution that's pulling in, running it against an anger script, trying to count instructions with something like pin tool, things of that nature, which are good things to know. But if I'm going through the effort to make a challenge hitting all those points I mentioned before, it defeats the purpose if those solutions still work. So coming up with an idea of something that will make those solutions not work, but if you can do the work to reverse engineer it well enough that you understand exactly what everything's doing, and then extract the problem out of the binary in something that you can work with more easily, and then you can come up with a solution. That's what I try to target with all of my challenges there. So it's just finding and trying to find something that meets all of those requirements.
Yeah, that's crazy. And I'm pretty sure you threw off a lot of folks during the we lost Towel. But yeah, I'm pretty sure he threw off a lot of folks during the NordSec 2020 edition with the QR code challenge. We've heard a lot about it, and I think like as much as it was hard, people kind of liked trying it. But like having like some sort of hints on how all these are getting solved in here is pretty cool. And yeah, and then like how long you've been like part of the NordSec community and like just in general like the cybersecurity community in Montreal?
I did my first CTF, which was really my first introduction to cybersecurity from anything that was non-trivial, in 2014 actually. I did that, and that was the same year that I signed up for Ring 0 CTF, which is how I got introduced into NorthSec. So for those who are unaware, Mr. Unicoder, Charles, runs a CTF platform called Ring 0 team. So I signed up for that and just started solving stuff and having fun. And I didn't know a whole lot of stuff when I started, and I still go back and read old write-ups of mine and cringe at them. But that was a good way to learn. So that's from there. He was involved in the NorthSec community, so that's how I got involved with NorthSec, and so I attended in person, did a workshop 1 year, and then started making challenges for the CTF to come up with some good things for people to solve.
Yeah, that's great, and it's really nice to have you every year. So yeah, cool. I mean, we don't have much time for like a full blown interview, we usually do, but thank you again for the challenge and the write up. That was great, and I'm sure we can expect more of OCaml on Ring Zero in the future. So that's pretty cool.
We'll see. I don't want to beat a dead camel, if you get what I'm saying.
Yeah, but that's great. It was like a very refreshing topic, but I mean refreshing for what it's worth.
Well, thank you. That's what I'm going for there. So that's good to hear that's working out. So thank you guys for having me. It looks like I'm going to sign off, and you guys have some Jackbox going on. So enjoy that, and thanks for coming to the Monterey Hack session and participating.
Yep, thank you, and yeah, thanks again for participating today. It was a great edition. Feel free to ask all some questions if you have any more questions. You might be around a bit later. And yeah, so also we're always looking for volunteers for future editions. So if you want to present something, reach out to us, and we can definitely find you a spot to present something, just like Towel did today. And this is how we build a strong community, is by sharing ideas together. So it would be very fun to have any of you here on stage in the future. And yeah, that kind of concludes the streaming part of the evening. So we will be moving. So I invite everyone to move to the Benelux Virtuel channel on Discord. We'll be having some Jackbox board games together, and it's more like a chill part of the evening. It will not be streamed, so it's kind of a good time to sign off on Twitch. And thanks again for coming, and see you on the next edition. Goodbye.